In this video, we are going to do some example calculations where we solve quadratics with square roots. And as you can see, I have listed out our process that we will follow on the side. The first thing that you have to do to be able to solve by square roots is you have to isolate the quantity being squared. So on one side, you should just have something squared. You notice in this problem, we've got a 2 that does not have an exponent. So in this problem, we will have to isolate. If you notice in our first one, we are okay because there's only the x being squared on one side, and then everything else is on the other side. So we can now move on to our second step where we take the square root of both sides. When I take the square root of both sides, we know that the square root of x squared is just x. And then the square root of 81, we can calculate is 9. But I do need to remember my plus or minus sign. So there are two numbers that multiply to give us 81. We could have positive 9 or negative 9. And then you might need to do inverse operations to get x by itself. Because x is already by itself, we're done. So sometimes solving by square roots can be a lot faster than trying to factor, even though this is actually factorable. So for our second one, I've added in a step. We have to use the inverse operations to isolate the quantity being squared, because there is a 2 on the same side as the x squared. So I can divide by 2, because remember that's multiplication, so the opposite of multiplication is division, and divide by 2. This was isolate the quantity squared. And we're going to get x squared equals 49. Now that x squared is by itself, you see it looks like this problem here. We can square root both sides. So now that I'm square rooting both sides, we know the square root of x squared is just x. And the square root of 49, we remember our plus or minus is going to be plus or minus 7. And there is nothing, x is already isolated, so we don't have to do the third step. Now let's look at a third example. In this third example, we already have something being squared. So there's nothing to isolate for our first step. Because although there's stuff with the x, everything on this side has been raised to a single power. So we can go straight to step 2. So we see that it is already isolated. So we are going to straight to take the square roots. And we get the square root on one side and the square root on the other. When I take the square root of x plus 6 squared, this and this cross out, and we're going to get x plus 6. But is there a number that gives us the square root, that gives us 38? In this case, no. So we are going to leave it as plus or minus the square root of 38. You notice that I am leaving this as an exact value. I am not writing it as a decimal. And now we are going to isolate x. If I want to get x by itself, I am going to subtract 6 on both sides. And think back to when we learned about simplifying radicals. These radicals are not like terms. This guy does not have a radical, whereas this one does. So we are going to write our answer as -6 plus or minus the square root of 38. Yes, this is an incredibly ugly number, but when we go, but it is an exact value, and we didn't have to graph this one. We could do it using these two steps. So this one would not have been easy to factor. You really couldn't factor it. But we were still able to write the exact value as the answer by following our process. So let's try one more example. We have 2x squared minus 6 equals 30. In this case, x is not isolated. So we are going to have to isolate x by doing inverse operations. So I could add 6 on this side and add 6 on this side. Remember, you undo addition and subtraction before multiplication and division. So I'm going to get 2x squared equals 36. This still is not isolated. Now this problem looks like our second example. So I still have to isolate by dividing by 2. You notice that this is just like you would solve a regular equation, but when we get here, we get x squared equals 18. Now you can square root both sides. And when I square root both sides, the square root of x squared is just x. And we will simplify if possible. So I know the square root of 18, that is 2 times 9, which is 3 times 3. So that gives me, oh, that's supposed to be a 3. 2 times 3 times 3. I see this pair. 3 times 3 is 9, so that's the square root of 9, which is 3 radical 2. So x is going to equal plus or minus 3 root 2. So you notice that in this case, we had to simplify the radical if possible. So in our first one, we were able to simplify and just get a whole number because we know the square root of 81. In our second problem, we had to go back. We knew that the square root of 49 is 7. In the third problem, we left our radical the way it was because it cannot be simplified. And in our fourth example, we did simplify it to 3 root 2. And we do see that x is by itself, so our problem was done. So make sure that you follow our process. In the next video, we will review simplifying radicals because it is a critical step in using square roots to solve quadratics. Thank you.